representations of data. Example 4. So we have to complete the table and then do a cumulative frequency graph. So at the moment we've got group data and the data is rounded. We can see there are gaps between these numbers here. Cumulative frequencies. The upper class boundaries will be 79.5, 89.5, 99.5, 109.5. Cumulative frequency always starts from 0 when we're looking at graphs. So I'll need a value here, which following the pattern here would be 69.5. The coordinates of the first point on the cumulative frequency graph, well, it's not always the origin. Here's the first point. Our data value is 69.5. That's on the horizontal axis. Cumulative frequency is on the vertical axis, and that's 0. So this will be the first point. It's not the origin in this case. Sometimes it is, but not in this case. We join our points together either with a smooth curve or with straight lines. If we use straight lines from point to point, we're assuming that the data is evenly distributed between those points. The maximum cumulative frequency value is 70. So starting from 70, if we halve that, we get 35. Half the 35, we get 17.5. Multiply this by 3, we get 52.5. And then if we follow these lines to the graph, we get these values. So this is the one in the middle, because we halved the 70, and that gives us the median. If we halve the median, this value is 17.5, and again if we follow this path here, this is our lower quartile. 3 times the lower quartile is the upper quartile. So following this line here, 97.5, this is the upper quartile. The smallest possible value is 69.5 and the largest 109.5. We can compare our lower quartile, median and upper quartile with the interpolation formula, which is what I've done here. So lower quartile, median, upper quartile, and you'll see that these values are very close to these. To work out the 80th percentile, so we need a formula, 0.8 because it's 80 times n, where n is the number of data values that we've got, which is 70. So 0.8 times 70, the 56th value. So this is the location of the 80th percentile. So we go to the 56th value. So starting from here, cumulative frequency, that's the 5th value, we've reached the 10th, we've now reached the 56th value. Go along, come straight down, and that's the value that we're after, 99 grams. This is the 80th percentile. It means 80% of the data lies below 99 grams and 20% of the data lies above 99 grams. And we can write these in probability terms as well, like this. So if a single item was chosen randomly, the probability that its weight is less than 99 grams is 0.8, and the probability that its weight is greater than 99 grams is 0.2. Part D, px less than 80. So this is a weight. 80, we go to the cumulative frequency curve, and we're going the opposite direction this time because we're starting with a data value, and that value there is 9. So that's showing us that this is 9, so this has to be 61 because the total there is 70. So less than 80, 9 items. Greater than 80, 61 items. 9 items out of a total of 70. So, and we could also state that the probability that a randomly chosen item has a weight greater than 80 grams is 61 items out of 70. Part E. So we're given the probability this time, and we have to work out this unknown data value. So 0.7 or 70% is actually the 70th percentile. The location of the 70th percentile is 0.7 times n. So 0.7 times, and n is the total number of data values that we have, which is 70. So we're looking for the 49th data value. So cumulative frequency, So we're up to the 5th value, the 10th, and if we keep going along, we've reached the 49th value. Come along here, straight down, 96 grams. So the 70th percentile is 96 grams. This unknown value k is 96 grams. And we can write that in probability terms like this. So px less than 96, which is what k is equal to 0.7. For practice, try these questions. So this exercise on outliers, box plots, cumulative frequency graphs, and a mixture of all the above, comparing data, and you'll notice that histograms is absent from the list. I've covered histograms in separate videos. There's more to histograms than there is to these simple topics.